Hello everyone, so in this video, let us talk about the second problem from the latest LEET Code Weekly Contest 382, problem name find the maximum number of elements in a subset. Okay, so what this problem statement is all about, what you can say is that you are given an array of positive integer nums, as you can see here. You need to select a subset of nums which satisfy the following conditions. You can place the selected number of elements in zero index array in such the following pattern. So you have to select a subset, like any number of elements in this, you can select a pattern and you have to put it in this pattern, which means that you have selected some elements and it should be in this pattern that there is some x, a common base. So x to the power 2, x to the power 4, till some common number and then they decrease down to the same x. So as you can see here, which means that there should be some base power 2, 2, 4, 6 and 8. Let's go so on to till a number and then backtrack to the normal point. So all should be some sort of this pattern. So as you can see that this is a base 2 pattern of the same thing. So 2, 4, then you can say then 2, 4 and then 16. So it is 2 to the power 4 and so on, and then backtrack to let's say 4 and 2. Okay, so what you can say is that we have to take this pattern into account. A common base should be there, and then all of them should be like 2, 4, and so on till a pattern which matches out. This is also like see, this is also same like 3 and 3 to the power 2, which is like 9, and then again 3. So this has to be pattern. This k can be anything. You just have to go till this in a like in this manner only. Okay, just like 1, 2, 4, then 8, and so on. Okay, until and then it has to decrease down again, then 4, 2, 1, and so on. Okay, this has to be power of some x. I just have to find out the maximum number of elements you can form and take out as a subset from here to satisfy the condition. How can you solve it out? The conditions are pretty much long only. You cannot do this in a very brute force way. So what you can do here is, what I actually understood here is, like, let's say first find out some basic iterations from these examples as well. Always take a look into different examples. If we have only one, if we have only one, let's say a lot of ones, then it can always satisfy this condition, because one, I can put 1 to the power of like 0, like this is not 0, like 1 to the power of 1, sorry. So 1 to the power of 1, and 1 to the power of 2, 1 to the power of 4, and so on, and then 1 to the power of 2 and 1 to the power of 1. So if I have ones, how many ones I have, that can actually helpful to define out all of those ones can be taken. Not all ones, but actually what you can see here is that they always form in this pattern. Okay, they actually have to go till a k, so there always should be some sort of a this should be some sort of a mountain, you can assume. Okay, like there is some x to the power of 1, x to the power of 2, and then they'll go to x to the power of k, and then they again drop down to x. Okay, so there should be always a one element in the middle, and then there should be elements like you can say surrounding it. So 1, 1, then 1, 1. So it can be one, like the total number of elements in the final output can be 1 or 3 elements or 5 elements or 7 elements. I hope you understand. So that is some you can directly find out these observations. So the thing is that if I have a lot of ones, then also I can put one like this, and then like it can be either 1 or 3 ones or 5 ones or 7 ones, because there should be somewhat some sort of a pyramid like this, that this will be 1 to the power of 1, this will be 1 to the power of 2, 1 to the power of 4, then 1 to the power of 8, 1 to the power of 4, 1 to the power of 2, 1 to the power of 1. I hope you understand, and all of them boils down to 1. So that is why you can get a 7 number of ones as well. So that is one of the things, like an edge case that you can think of pretty much simply and very easily, that if you have all ones and how many ones you can take out to form a particular answer. Okay. Now the other thing is that, okay, how can we form a pattern around here and how we can check it out? The overall idea here is that we have to find out some x to the power. So x to the power means that it is always a square root. If it is a square root, what you can say is that it is x. So it is x. This is x square. So like you can take out a square root and it becomes x. If you take a square root of x4, it becomes x square, which means that any number I have, and if I do a square root of it, and if the previous number, like the number which is formed, also exists, then they can start forming a pattern. So which means that I should go from back to front, from the very large numbers, from the very large numbers. Also, all these numbers should occur in pattern as well, not pattern, a pair. So which means that if I have 4, then I should also have 4, because they as I've told you, this is some sort of a you can say a pyramid, or you can say a mountain. So if I have x to the power of 1 here, there should also be an x to the power 1 in the same pattern. So if I have x to the power 2, x to the power 2 also come here. So everything should be in a pattern. So if a number is taken to be in this consideration in the subset, they should also be occurring in some pair. Okay, so for which I have to some sort of a store the count, like how much time every number is occurring, so that we can only take the ones which are occurring in pairs. So I have to first find out the count of every number as well. So we can make a map and store whatever is the count of every number. Then we have to go from very larger number in the maps, the largest number, to the smaller number. Okay, let's say we have x to the power of 16. So we'll take 16, and then what we'll do is that we will store 16 and check that whether we have already calculated of x to the power of 8 also. Okay, so if we have already values for x to the power 8, we can also store that and take that values as well and then add it. So that is how we can form some sort of a DP table. So we are using the previous values and checking out whether I have how much numbers I have for x to the power of any number. Let's say we have any number. Let's say 3. I've taken any number. Let's say it is 8. So I've underroot it. I'll find out 4. So I'll check that whether 4 exists, because if 4 exists, then also that can easily form a pattern. So if 4 exists, then I'll underroot it to 2 exist. So then if 2 exists, so 2, 4, 8, they can form a pattern. So I will have to take 8, but I have to also ensure that 2 should occur 2 times at least 2 times. Then only I can take 4 here and 4 here in the actual like mountain data for me. I hope you understand. That's the overall idea. We will use a DP table here, so that for every number we'll check that whether it's corresponding underroot present here. And if it's present, then if it's present 2 times, I will take that and add it to this count that I am forming a pattern here. Okay, that's the overall idea here. I'll go through the code part now to make it more understandable. That's the overall idea that we'll use here. So what we have done is that we have created a map, and this is a DP map, and this is the actual count map. So this we have iterated over every number and find out the count of it. Then what we have done is we have initialized and find out how many number of ones are there. Okay, and we have to make it the power of 1 or 3 or 5 and so on. So 1 is there, and subtracted how many numbers are there which you can form on either sides. So mod 2, and this will actually help you to find out how many ones you can take in the actual answer, like the very basic series you can form with ones only, like how many one series you can form, you can find out using this answer. Then you can do a for loop, all the numbers from back to front and to front, and you can check that whether what, like if it is greater than 2, what is the square root. We can find out square root of that. Okay, then you can find out the square root. So what we have done is for every number, you can either do a square root, like either you do a square root. So let's say if we can either find out x square and find out for x square x, or for every x we can find out x square, whether for every x there exists an x square, for x square there exists how many x4s are there, and so on, because we are going from back to front. If we are going from front to back, we will take every number and find out x under root. Okay, so what we have done is for every number we have multiplied it twice and check that whether if I have taken x as the base and we have x square, we are doing x square. If we are taking x as a base, we are taking x1. So whether x square exists. For x square when will come, whether x4 exists. Okay, so what we have done is for every number value, I'm checking that whether value into value exists. If value into value exists, then what we'll do is then 2 times what is the value into value part, because that's the number of value into value, this value, how much count is there, like DP value for this particular state plus 2, because I'm taking at least 2, the count should be at least 2. Okay, the count should be at least 2, then only we can take 2 and then this value. And that is how we can keep on forming this particular series, and the end we will actually maximize it over this DP value for this particular value, for every value possible. And then we can get an answer. Okay, that's the overall idea. This is just using DP to form for every base, for every x, whether x square exists, for the x square which x4 exists. Okay, and then we will storing it in some DP table and maximizing over all the DP values. Okay, that's all logical code part for this particular problem. If you still have any doubts, you can mention it in the comment box of this particular video. I will see you in the next one. Like coding, and bye.